You know when you see a robot dog navigating a rocky trail and you wonder, how in the world does it not fall? Well, it's not just seeing with a camera, it's actually building a complete digital reality inside its head, moment by moment. Today, we're going to break down how robots really perceive the world. So seriously, how do they do it? You might think they just have a couple of cameras for eyes, but the reality is way more complex, and honestly, a lot cooler. It's less about seeing a picture and more about building a complete, actionable understanding of everything around them. And that right there is the fundamental difference. See, when we look at a room, our brains just effortlessly process this rich, colorful scene. But for a robot, totally different ballgame. Its brain has a completely different goal. It's on a mission for pure, raw, actionable data. This really puts it in perspective. On the left, our brain instantly recognizes a scene, right? We see a chair, a table, a cup. But our robot sensors see the image on the right, a massive collection of raw data points floating in 3D space. It doesn't see a chair yet. It just sees an arrangement of surfaces it knows it can't walk through. So, to make any sense of all those data points, the robot has to answer some really key questions, and fast. First, it has to define the edges of things to figure out where one object begins and another one ends. Then, it's got to track motion, what's moving, and where is it headed. And maybe most importantly, depth. How far away is everything? Answering these is absolutely critical for just existing in the world. Okay, so let's get into the hardware. To gather all this crucial data, robots are packed with this incredible toolkit of sensors, and each one has a very specific job to do. These are its high-tech eyes. First up is LiDAR. You've probably seen these little spinning pucks on top of self-driving cars. What it's doing is shooting out thousands of laser beams and timing how long they take to bounce back. This creates a hyper-accurate 3D map made of millions of points. They call it a point cloud, and it's perfect for measuring the exact shape and distance of everything. Next, we have stereo vision. Now this is just brilliantly simple because it works exactly like our own eyes. By having two cameras set just a little bit apart, the robot can compare the two different images it sees. Those tiny differences between them are all its processor needs to calculate depth and distance with some pretty remarkable accuracy. And rounding out the basic toolkit, we have infrared sensors. Honestly, these are the unsung heroes. They don't care if it's broad daylight or pitch black. By detecting heat signatures, they provide a whole other layer of data, making sure the robot can perceive its environment no matter what the lighting is like. So the robot's got this fire hose of raw data streaming in from LiDAR, from its cameras, from infrared. What happens next? Well, this is where the real magic begins. It has to take that chaotic flood of information and build a coherent digital world out of it. The process in concept is actually pretty simple. First, the robot senses the world with its toolkit. Second, it maps all that data into a 3D model. And finally, based on that map, it can act. This sense, map, act cycle, that's the fundamental loop of robotic intelligence. And this is a really key point. We're not talking about a static map, like something you'd pull up on your phone. No way. This is more like a living, breathing digital twin of the robot's immediate surroundings, and it's constantly updating hundreds of times every second to reflect every single change. So what does this internal map actually look like? Well, it starts as that 3D point cloud we talked about, basically a swarm of dots in space. But then, the software plays a high-tech game of connect the dots, stretching a digital mesh between them to form solid surfaces and objects. This internal blueprint becomes the robot's entire reality. It's how it knows, I am here, and that object is over there. Now, having a map is great and all, but its real purpose is to enable action. So let's look at how this detailed digital world lets the robot make decisions and move with just incredible speed and precision. 15 milliseconds. Just let that sink in for a second. That's about 20 times faster than the blink of a human eye. Keep that number in your head. Because that number is the key. Using its constantly updating 3D map, the robot's AI can process its entire environment and decide on its very next move in that tiny fraction of a second. It's a staggering fusion of perception and calculation. This mind-boggling speed is what allows for such fluid, intelligent action. We're talking about calculating the perfect foot placement to walk across a pile of rocks, or identifying one specific tool on a messy table and grabbing it, or instantly dodging a person who suddenly walks in front of it. It's all powered by this lightning-fast cycle. So as we wrap this up, I kind of want to reframe how we think about this whole process. Because after everything we've looked at, it's pretty clear that what these machines are doing is so much more profound than just seeing. So the next time you see a robot just kind of pause and scan a room, remember what's actually happening under the hood. It's not just passively watching, it is actively sensing, mapping, and processing its world in real time. It is, for all intents and purposes, thinking. And that leaves us with a really fascinating question to chew on. As these systems get more and more advanced, if a robot is truly thinking about the world it perceives, what will it eventually see that we can't?